Hello everyone, my name is Rajesh Kumar and I'm your DevOps, SRE, DevSecOps coach. I have close to 18 plus years of experience working in multiple MNCs around the globe and having in-depth knowledge of DevOps, SRE and DevSecOps. So I would like to introduce you one certification program in a DevOps, and that is we call it DevOps Certified Professional. Now this is a 2 months of program, 25 tools of DevOps you will learn, and apart from that you will also get the access to the LMS, lifetime access to the videos portal. It's a certification program, and you will have 25 assignments and 2 projects along with it. It's a completely weekend program, so here you have classes on Saturday and Sunday. So as part of this course, you will learn multiple things. Here you see that you will learn Linux, AWS, Docker, Jira, Confluence, Python, Git with GitHub, SonarQube, Maven, Gradle, Packer, Artifactory, Selenium, JMeter, Ansible, Kubernetes, Helm, Terraform, Jenkins, Datadog, Splunk, and Neuralink. Now, how do we, apply for this? So how can you reach out to us? So you have a WhatsApp number and email ID. So please reach out to us, and we'll help you to onboard this program. Apart from this DevOps certified professional programs, we are offering other certifications as well in a DevSecOps, SRE, and one of the very comprehensive programs which we have is in Master in DevOps Engineering. Yeah, so feel free to get in touch with us and then enroll for it. Thank you. So here, if you see that what we did, somewhere, okay, I lost this plan, then code, and then what we did, analysis, and then second one is build. So for the planning, we learned Jira, Confluence. For coding, we learn Git, Python. For analysis, we learn Sonar Q. So let's say analysis is successful, quality gate is passed. So what we have to do? Build. Correct now, all of you?
Yes.
And this is what we are focusing. So here I will teach you 2 tools for build. One is Maven and another one
Where?
is Gradle. Okay. So why these 2 tools? I'll discuss while showing you the demo. So build. So first thing, what is Maven? So it's a build tool, very simple. Now you will say, Rajesh, why we need it? So very simple answer is build automation. So then you'll say, okay, automation for build. What we do in the build? So in the build, what we do is like we download the source code, download the dependent libraries, create few directories, compile the code, unit test the code, package the code, and upload to archive location, which is the next topic. Next weekend, I'll cover that one, Artifactory and something like that. So these are the things we do in the build. So then you'll say, okay, why we need to automate then? It's like it's okay. I can do manually also. So we need to automate because you do compiling the code, testing the code, packaging the code. You do how many times in a day? You do hundreds of times. So if we are humans, we are not going to do the repetitive work. So we have to automate. Simple. So now we have to automate all the build process with the same thing. We modify the code, build, we compile, unit testing, package, and then test this. So these are the things we do hundreds of times. Every developers at least 20 times in a day, they do that. So we need to automate this process. But then you'll ask, Rajesh, why we need to learn new tool, Maven? Why can't we do automation through shell scripting or bash scripting in Windows or something like that? Or maybe Perl. So regions are also very simple. Build automation, when you use Maven and Gradle compared to other scripting tool, Maven for build automation is best solution because Maven is easy to implement for the build automation, easy to learn, easy to manage, easy to extend, easy to troubleshoot, easy to debug. Everything is easy for build automation compared to other tools, because there is a specialization for every language, every scripting language, or every programming language, every tools, there is a specialization. So basically Maven is developed only for automating the build automation. You cannot use Maven for something else. So that's the reason it's faster, easier, better, and everyone is using that. Make sense, all of you?
Yeah.
Make sense? So now, okay, so build tool is a build management tool. Now here, next questions you will say, or one more thing, few things I want to add it. It's free, it's open source, it's developed in Java. That means you need a Java to run. And here, one more thing, for Java only. Primarily, this is developed for Java. Okay, so it's developed in Java for Java project automation only, build automation only. And if you want to use multi other projects, let's say .NET, then you have to use MS Build. If you're using this one Python, then Rake. Gradle you can use for the .NET also, Rake also, Java also, C++ also. So Gradle is for many languages actually. Okay, so these are the some of the introduction of Maven. Now next question is how to install it. So basically you know that uh, when it's written in Java, you need to have a OpenJDK or JDK or Oracle JDK, whatever it is. So I have it. Let me show you that Java installation in my this one machine. Here you have a Java 8, Java 11, Java JRE 1.8. Now this is I have activated because only one Java you can activate one at one time. So how do I did how did I did that? So go to the environment variable, and here set the Java home, which is here, and add this path somewhere here, bin path. Mind it, it will be in the recording. So if you don't know how to do that in Java, you can do that. So this one. So I have installed the JDK 11. Now from where to download? So typically for all of my sessions I use the Open JDK. Why? Because it's a little less time consuming. So if you see that from where you download, just type Java install, and here it is. Now this URL, just remember that instructions you may not have for everything, but this URL will help you for that. This one. Okay, so here if you go, and you can download all the Java version for everything. It's just download, copy, paste. That's all, nothing else, and set in the path. So like that, download, extract. So right now we have 20 up to the 20 release latest. So like that. So that is done. So first thing, if you want to install it, you have to have a Java, and second thing, you have to download Maven, extract it, and set in the path. Same case with the Maven also. How? So let me show you. Here download Maven, and you see from here you can download. Go for the zip file. This is the one. Don't go for the SRC, because these are the source code. This is the binary. So go for binary. Tarball also okay. Zip file is also okay. It's up to you. Now you download this one and extract it. Typically you know that by now I extracted everything under C tools. So here I extracted it. I don't want to use the download folder, my or desktop folder and all. So every tools I have put it in under this. So like this. Now what you need to do is this path you need to set in the path environment variable. That's all. So env here. Let me show you the path environment variable. Here it is. Edit. Look at it little bit carefully. It should be here. It is. So I added it. That's all. So Maven is installed and set in the path also. Installation is like copying and extracting, that's all, and set in the path. Now how do we verify? So I'll go here and just type mbn, that's all. So mbn is, if it's not saying command not found, that means it's installed. Okay, so mbn is a command for the Maven. So are you comfortable, all of you? Okay, so now guys, how to automate it? That is the question. How to automate it, guys? You know one thing, the advantage of Maven is Maven says, please hear me out. Maven says, hey, if you follow me, I will automate everything for you. Yes, that's true. Maven says, if you follow me, then I will automate for everything for you. So you want to understand this way? So let's go to this way. Here Ant versus Maven. You know, Ant, MS Build, these are the same category of tools. Okay, look at this here. You want to create a directory. Very first day, what you'll do when you start any new project, you want to create a directory structure for coding, right? So this one person will do and commit in the Git. So here in Maven, you see automated, and you decide your own structure. Build preparation automatic, and you decide your own way. Library dependencies, it's a manumatic. Here and manual, you have to download manually. Compile automated, testing automated, packaging automated, versioning automated, deployment automated, site generation automated, cleanup automated. So these are the things you do in the build automation, and all this thing in Maven is automated, whereas in Ant you have to write your own logic. Understanding, right, all of you? So Maven says, hey, if you know me, if you know how I works, then I will automate every task for you, and if you for you, and it will save time. So what is the background for this? Let me tell you here. Simple. It's a story is very simple. Basically, Maven has come from the Apache, and if you know, Apache is a foundation open source community, and they have thousands of project based on Java. Thousands of, remember that, thousands of projects based on Java. So they were struggling for something. So so engineers will work for one project, and they will understand the build setup. Then when they migrate to some other project, it'll be having very hard time for them to understanding the build process. They will spend 10 days, 15 days just to understand the build setup, testing process, compilation process, packaging process. So they were wasting time. So what Apache decided, let's do one thing. See, in every project we do compile, test, package, and all this thing, every project. So why can't we set a standard? Like, we know that, okay, these are the fixed directory structure. Here you have to store the source code, here you have to store the test code, here you have this is the download, this is the from where you can download the dependency, this is how that this directory will be compiled, this directory will be testing, this directory and this file will be packaged. Everything is fixed, because every project we do the same thing, repetitive stuff. And that is where the Apache Maven is born. Did you understand the problem statement and how beautifully they solved it? All of you? So yeah, Maven can automate everything for you. So what you need to do? So you need to understand how Maven works. That's all. So when I type Maven, here it says no goal. Now I need to understand what is goal. Here you say life cycle. I need to understand what is life cycle. Here is a phase. I need to understand phase. Here you have plugins. I need to understand what is plugin. These are the phases. What are these? Validate. What is test compile? What is test? What is package? What is package here? What is a test, post integration, install, deploy? What exactly these are? As I said, Maven says, if you know me, I will automate for you. Let's start with the Maven lifecycle. Okay, so here just type Maven lifecycle. Okay, I just need this blog, so I'll open up a new one. Okay, Maven lifecycle. Guys, life cycle means life cycle. We do have a life cycle. Life cycle, something to start to end. Simple. That is what life cycle. So look at this. This is the human life cycle. We born to die, and we do something. So can you die before without born? No. Can you become an adult without a kid? No. Can you become a kid without a born? No. It's like a life cycle. One has to happen to enable the second one. You cannot jump. Mind it. You cannot jump. Correct now? So same way, these are the phases of software development life cycle. You do analysis, then only you can design. You can design, then only you can develop. You can develop, then only you can test. All these are life cycle of the software project. You know that. But you know what? For build automation also, they have a life cycle. So what are the life cycle? So default life cycle for every project. So first thing, I'll put it, not complicate this all stuff, but here I'll put it in very simple way. Life cycle means uh, there's a three life cycle which we have here in the Maven: default, clean, and site. So default life cycle applicable for every projects. So in the default life cycle, mind it, we have a phases. So some of the popular phases which we have, okay, these are the phases. Okay, popular phases we have, which is called compile, which is called test, then package, and then like that. Only up to this is okay. I don't want to cover and complicate everything. So compile, test, package, only this one. Now actually here you have so many phases, 24 phases you have it. Okay, look at this. This is here in the default you have a 24 phases, but actually in reality we don't use all this thing. By the way, I'm audible because I'm seeing the some network issues. All of you.
Yes. Yes. Yeah.
So for managing the build automation, Maven has given three life cycle. Most important is default, which is default for every project, and they have a multiple phases. Here validate, but I'm choosing only few of them, which is important. We use 99.99%. Compile, test, package. So now mind it, simple logic. You compile, you can do when you want to do the test. You want to bring the project into the test phase. You have to compile. You want to package, you have to test, and when you want to test, you want to compile. So these are the interrelated. Okay, you cannot jump from compile to package without a testing. It's like that. It's like a life cycle rule. So these are the phases which you have. Okay, and again these are the phases, and this is a clean life cycle phases, and this is a site life cycle phases. Now you see that simple flow: validate, compile, test, package, integration. So this has to be in a sync. So now you understood that what is life cycle, and then you understand what is the phases. So this is the governed by Maven. Are you understanding, all of you? Hello?
Yes.
Okay. So now you will say, see, you have a source code available, and then you say Maven, hey Maven, because you are automated, can you compile my project, or can you test my project? Can you package my project? That means I want to reach up to here, or I want to read up to here, or I want to reach up to here. So how can you instruct that? So to take that Maven to this particular uh, project, to that particular phases, how can you reach it? So this magic mantra is the instruction which you call it a goal. So when you want to take a project to the compile phase, you will use compile goal. It's like a instruction. When you want to do the test, you will call test. When you want to take it to the package, package. Mind it here, this name is same, but conceptually it's a different. Phase is like a the phase of your build project, but compile goal means it's a way to take that your project to that phase. Coincidentally, it's a same to avoid the confusion. Okay, so phase concept is different, goal is different. Goal is a way to take that project to that phase. Are you understanding, all of you? Hello.
Yes. Yes.
Now the
Yes.
question is, goal is a goal is a this one. This is the phases. So goal will take you that this particular project to the compile phase. So this has to be some feature. So that is where the plugin is coming into the picture. So plugin is equal to feature. There are two features we have, two types of feature we have in Maven. One is a core, which is built in. So this compile, goal, test and package, these are the goal is coming from the plugin. That's a core plugin. And then some of the external plugin, community plugins also you can say that. So these plugins is core plugins. So for example, if I show you this one, look at this here very carefully. They said, hey, use the plugin name and goal name, or use the plugin group ID, artifact ID, version and goal name. So this is a pattern you have to call. So goal is basically, I'll put it in this way. Plugin is basically is a jar file. Okay, jar file, and goal is basically calling the main method of that particular jar file, one of the function of the jar file. Okay, so like this. So now what do we understand? Yes, we understand Maven have a life cycle to manage build automation project. There are three life cycles. One is a default, another one is site, and another one is compile. So each life cycle we have a certain phases which you can see on my screen, and most important one which is compile phase, which is here, test phase which is here, and package phase which is here. That's the most important you use every time. And then and then each phases to bring it we have a goal, and this goal coincidentally is matching. Okay, so these are the goals actually. See here, compile phase, compile goal. Here test phase, test goal. This SRE file you see is a plugin name. Compiler which you see is a plugin name. Okay, so compile is a goal, this is the plugin name, like this. So now did you understand this concept of life cycle, phase and goal, all of you, and plugin, all of you?
So
No,
plugin can
about
be
the
any plugin compatible that you can use, but it's
So
specified over
plugin
there.
is equal to extra feature or feature only, not extra feature. And there are two kind of plugins. Core means it's a built-in, okay, and you can also get it more features added if you want it. Hundreds of plugin has been developed by community. So if you want those features, you can just download the jar file, copy in the Maven one directory, which I'll show you. That's just a second. Hold on. This is Maven file, right? So here you just copy this jar file, and that these are the default one, okay? So copy that, and then that features you can use it. Got it, all of you?
Yes.
All of you? Okay, so now one thing you need to know, what is a group ID and what is an artifact ID, what is a version, and what is a package type. So what is this? Guys, group ID and artifact ID is something which is a packaging structure of your source code. Okay, so for example, let's say I'll give you an example, Microsoft. So let's say you are the Microsoft CEO. So Microsoft is a company name, and after CTO, not CEO. Okay, Microsoft is a company name, and then after that Microsoft we have Office. Office we have a Word, we have Slide, PowerPoint, and then some common libraries also there. So this is the structure. Now this common can be used here also and here also. So when the programmers will write a code, how do they structure the code? So when the programmers, whether it's a Java programmer, .NET, Python, or what exactly, don't care. They will have a structure like this. They will write the code inside. So they will have SRC directory, source code, and then they will have a, let's say, Java. And inside that they'll create one more directory. So this is the structure of the code, okay? And then inside that they will write, okay, they will write com dot microsoft dot office. So this is a directory. Just avoid the spelling mistake, okay? So there's one directory com, after that one directory, subdirectory Microsoft, after that office. So these are the subdirectory will be created. So here com means company, Microsoft Office, and now inside that they will keep it word, Okay, and then this word.jar file will be there, or any other packages. In this here, oh, sorry, a word.java file, sorry, not Java, Java file will be there. And the Java file, you will write something like package, it's the content of it, package com dot Microsoft Office dot Word. So this is your packaging structure for this particular jar file. So now this is the word. Okay, after that there is one more component which is called slide. Okay, so slide they want to use the word some of the common feature. Okay, so what they will do, they will also write package, there's own structure, they will have it, package dot slide, and then they will, this is the slide packaging structure, and they will import the package from the word, which is this one. So that means whatever the features you have here, you are importing the classes from there. Okay, and you are creating your own packages also. So this is how the structures people are making. So that's the reason you might see any code you go, you start with a package and import. Let me show you some example Java example GitHub code, something like that. And my God, so many. So see here. So this is the server code. Okay. And here you see SRC chat. Look at this. This is a structure. SRC under the chat is a structure. You can have multiple directories. So I explained you multiple directory. Here you see. So if you go to the file here, look at this. Because it is the only one directory which is chat. So here they have picked pack chat. Now if you see that this one they are importing. So in order to write a chat package, they are down, I mean, using some different library, and the library is located Java dot this one and this one and this one. Are you understanding, all of you, this concept? Hello, hello.
Yes.
So every programming language, you see this, every programming language, any programming language, you will see the structure. So the question was, what is the group ID and artifact ID and version and package? So group ID is equal to from Microsoft Office. So this is your group ID, and your artifact ID is Word. That means this is your package, and this is structure for your group company. Okay, so that way organizations use the, instead of rewriting the duplicate code, they use the different library which is already built by some other project, and they use it like that. So understood the group ID and artifact ID, all of you? All of you?
Yes.
Now, what is a version? So guys, in Maven, we have a two kind of version. One is a release and one is snapshot. So release means release one. So how do you represent the release one? 1.0 major, 1.1 minor, 1.1.1 patches, like that. But how do you represent the snapshot release, which is, so snapshot means not stable code. So you want to inform community, hey, this code is not stable, use it with care. So just add this name. People will be little careful while using this code. Now, what are the package supported in Maven? Because Maven is Java based. So you have a jar, var, ear, pom. These are the package supported by Maven. Okay, so more or less you have understood everything. So can we go ahead and follow Maven for doing all this stuff? All of you are clear?
Yes.
Okay, so guys, here I have to, first day of my project, I have to create a project directory structure. How do I do that? So for that, I need one command, and that command is just a second, Maven archetype. There's a plugin for everything, mind it. I don't know, it's not coming in the results. Here it is. So guys, the line which I am explaining it to you, just give me 2 seconds. This command will create the project directory structure. So command is basically this one. So what is this? Ambient. What is this? Archetype is a plugin name. What is this? Generates a goal which is coded in this. So this plugin will create a skeleton project directory structure what any projects may have to use it. Now you'll say, what is a extra thing which is added with hyphen d hyphen d hyphen d hyphen d and all? So this is the group ID you are passing, okay, and this is the name of your project, and these are some of the quick start and interactive more option, make it fail. So like that. So when you hit only this one, this option they will ask. Okay, so right now I don't want to ask, let them ask, so I put it up all this thing. So create one directory, Maven, mind it, empty directory, and then go to the command line and carefully run this command. Mind it, this command will create directory structure very first day of your project, and as per the things, this is the one I'm doing, automated directory structure. So now there is some issues here. Let me correct it. You'll not face these issues I'm facing because my system is little customized. So I'll just remove it. Done. So whatever, it will not throw an error. Now this command I rerun, and these are supposed to create a directory structure. Let's do that and see that. Done, guys. So directory structure has been created. Can I check this out? Look at this. Financial services is my artifact name. With that, they created directory structure. This is SRC. Inside that, here is a code for product. Here it will be code for testing the product. And this is the configuration file for each project. There will be pom.xml. So pom.xml means project object model. This basically, you can say, configuration file for your project. So what it will contain, let me show you. Whatever you pass through command line, it will contain that one only in a XML format. So just ignore this one, this line, because it's XML standard. What is the group ID? What is artifact ID? Default packaging, default version they have set it up. I did not pass this, they set it up. This is your company name, URL, and all stuff like that. Now this project is dependent on one JUnit packages. Why? I'll show you this one. So this is sample created. So you see that project directory structure created, and now this directory structure you can commit in the git, and now every developers and testing team will use for this same thing. Okay, see that directory structure, all of you. See, main, Java, com, company name, software, test, Java, company name, com, company name, software. This is the packaging structure. This is the packaging structure. Okay, so did you understand so far, guys, all of you? All of you?
Yes.
Okay, so now next thing is what to do. So guys, you have to code actually, right? So let me act like a developer. So I'm acting like a developer. Okay, I'm started coding. So I'll go to src main java com company name software here. So this is one code they have given you, sample code. If you want, you can check, see that structure which you see. So what I will do, I'll not complicate, copy paste. I'm writing one more code, and this is my extra code for the product. And now I have to change the class name. If you know Java, class name here, done guys, coding is completed. Here testing team will also add that test cases here. So right now there's one test cases which has come, demo hello world test cases. See here. Now you want to know why that dependency JUnit, because they have added default, we did not add it, but you see that here. So in order to compile this code, Maven needs JUnit library. So that's the reason dependency was there. So Maven has one very powerful feature which is called dependencies management feature. That means if you say that okay, your code has certain dependency of external libraries, so Maven will download that dependency for you from the internet. I'll tell you that how it works later. So because of that dependency. So guys, now if you understand that coding has been completed, what should I do? Compile, test and package. These are the three important things which I want to show you. So can I go ahead and compile? All of you, what do you think? All of you?
Yes.
So it's nothing great, guys. You know, Maven has said, if you follow me, I will automate everything. So I have not written even single line of the code, and I'm doing compilation of my project. Every developers will do the same thing. They will write a code and they will run compile test package, something like that. Very popular goals. By the way, my build is failed. Now if you see that, okay, so here is they saying, hey, you have to run this command in a place where you have pom.xml. So here I'll just go inside and then run this. So Maven compile. Again is failure. Now if I read the error, it says, hey, there is a problem. My compiler is built in 1.6 or 7, but there's some you're using Java 11 or something like that. So this is a known issues actually. You just put it in Google. Okay, these are known issues actually. So put it in Google. Here is a solution. Read it, this whole solutions. They're asking you to add this in a pom.xml. Copy it, go to the pom.xml property, add this automatically. It will solve. And carefully. This is a pattern is like this here, you see. Uh, so here dependency, there's one dependency. It can be multiple. Property, there's one property, there's another property. So here you are saying, hey, compiler source 1.8, target 1.8. These are the way to fix it quickly. I do not complicate Java stuff because you get lost. So I want just you to, look at this whole ecosystem. So tomorrow you have a Java project based on the Maven, you can know what you are doing. And you see, it's success. So you want to know, see compilations happen. So where is a class file? So here it is. Can I go and check this? Maven target directory will be created here where the compile code will be there, and classes com company name software. These are the two. Remember that I had two code for the product. I added one more. So this is your binaries. Now what to do now next? So see that automated everything. Now next thing is testing. So can I have one test cases? Remember that was given by the system only. So you can add more test cases also. Test. So simple. So Maven compile. After that, I'm going to do the testing. Remember, the testing will do the Maven will do the compilation again because it's a workflow, right? Life cycle. Life cycle never rules never break. So when you do the test, automatically it will compile also. But if you see that nothing to compile, this region everything was up to date. If there's a source code change, it would have been compiled. Now where is a report for the test cases? Here it is. In fact, here it is. So this location you have a test cases results. Now what to do? Package. See, packaging for that you have to remember jar. This is the version and this is the artifact name. So let's do the package. And oh, spelling mistake, I guess. Have to change this. Let get the error. Clear the screen. packeg package. So see, packaging we do compilation, then testing, and then packaging. Now these all are small project, okay? But if you run in the large project, it might take 30 minutes, half an hour, depends on the number of code in the source code and then test code. Okay, so enter. Done, guys. See, packaging is done. This package is created. Let me show you this. So now this is a snapshot package, okay? Here target, this is your package. And this is the package which you wanted. And you can upload these packages to some artifactor, which is I'll teach you next session. But yeah, now if you think the release has come, so modify this number, snapshot to this one, and do one more time packaging. Number, this is the release number, remember that. So now you are able to visualize that how it's easy to use it. Now you understood that why we use Maven for build automation, all of you. Because Maven says, hey, if you follow the process which I defined, which you follow the structure which I define, everything will be automated for each one of the developers. So now every developers, those who are using Maven for build automations, they will know what is the life cycle, what is the goal, what is the phases, what is the group ID, what is the artifact ID and all. And every engineers will have this same understanding. So no need to learn KT and TOT and this that on the build front. Are you understanding, all of you? Hello, hello. I'm audible.
Yes, sir. Yes, sir.
Great. So now, guys, next thing is one of the most important features which you have in Maven, and that's called dependency management system. What is all about? So here you see that your test code is dependent on JUnit library. So that means if you want to compile this code, JUnit library should be in the class path. So what programmer did, they added the JUnit library dependency in the pom.xml. If you see that here, group ID, artifact ID, version, and this jar file will be loaded during the test phase. So what exactly happening? So now you see that here, first thing, developer use that dependent libraries. Second thing, developer appended that dependency in the pom.xml, has to be done. Now Maven will manage this dependency. How? Let's understand this. So first thing, what happens? I'll tell you. Maven read the pom.xml. Now pom.xml will have a dependency like this. So this dependency, Maven will try to locate in local repo. Now you'll say, what is a Maven local repo? So let me show you. The Maven local repo is the user home.m2. This will be directly created when you use Maven here. This is the Maven local repo. So they will try to download they will try to locate that package in the Maven local repo. This is the location. If found, then that will set in the path, class path, and then use for the building and compilation and testing purpose. But let's say if it's not found, let's say this, let me check if it is found or not. So JUnit, go to just a second. Here, go to M2 repository. Let's match JUnit, 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 JUnit 3.8.1, 8.1, and this is the loading using test phase. So you have a here. So actually, if you look at this flow, Maven read the pom.xml, read the dependencies, try to locate the same dependency in the locate in local repo. If found, set in the class path. But if not found, mind it, if not found, download default from central repository. Now what is central repository? So central repository is repo.maven.apache.org.maven. So here let's show JUnit 3.8.2 or 1, and this is the jar file. So download from where? From the central repo to where? Local repo, and then set in the path. Let me show you the download activity. So what I'm doing right now, from the local, I'm deleting it. See here, JUnit, I deleted in front of you. And then I run the goal, which is called Maven package. And you see that it will download. Wait for a few seconds. See here. See, look at the download. Look at this, it's little fast here. And let me show you that. See, JUnit, look at the timestamp. And this is the JUnit, and here it is. So this is what it happens. So that's the reason we call it Maven is a dependency management system. Why? Because you just specify the dependency in the pom.xml and Maven will manage for you. So that dependency will download and set in the path. You don't have to do anything except adding this code in your pom.xml.
So
So if it is
this
another,
code that we added, that Maven Apache org and this JUnit 381, these details we will get on Maven website. Like how we know where to add
developer will know
this
that, no? See
formatting.
this, developer will know this, no? You as a let's say I am a developer, I am using this code, so I will have
Mm-hmm.
to add this which version you are using for JUnit, 3.8, 3.9,
Mm-hmm.
3.4. So they will do that for you. You can also do that by reading the
Okay.
little bit of Java and all,
Okay. Okay.
because here you have a
And the
multiple
format
version, no?
also is
See here.
format is standard for all pom.xml, right?
Yes, it's very pretty much standard. Okay, got it, all of you? So guys, this
Yes.
is so this is Maven. So for you, how it will be helpful. So guys, you need to understand. I am repeating. You may not be doing coding, but you need to understand what is a life cycle in Maven, how to install Maven, how to use Maven, what is the phases in Maven, what is a goal in Maven, which goal will do what in Maven, where these files will be created, target directory. What are the goals? So popular goals like compile, test, package, install. What is the dependency? What is a group ID? What is artifact ID? What is a version? What are the packaging type? And these are the things, if you understand, so you are done with the Maven. Are you understanding?
If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.